Because this is V naught. Here, see this branch consists of inductance and resistance. Therefore, this is replaced with parallel equivalent. We know that Z is equal to Z dash. Let it be Z dash. Z dash is equal to J omega L plus R. These two are connected in series. Y is equal to 1 by Z dash. That is equal to 1 by R plus J omega L. Now I will concentrate on this one, this branch. Series branch is converted into parallel branches. Rationalize this one with R minus J omega L by R minus J omega L. That is equal to R minus J omega L, A plus B into A minus B, A square minus B square. That is R square minus B square means J square. J square is minus 1, minus into minus plus. That is omega square L square. Omega square L square. That is equal to R by R square plus omega square L square plus here minus J omega L by R square plus omega square L square. Numerator and denominator is multiplied with J. That is equal to 1 by R square plus omega square L square by R. J into J, J square minus J square is minus 1, minus into minus plus. Here not omega, here 1 by J into J, J square. J square is minus 1, minus into minus plus. Here J R square plus omega square L square by omega L. This one is Y. We know that Y is equal to Y is 1 by suppose Y is the series combination is replaced with parallel combination. That is LP. Series combination is here L and R. Here Y belongs to this one. That is 1 by RP plus 1 by these two are connected in parallel. J omega LP. 1 by RP. Equating these two. Equating RP is equal to this one. J omega LP is equal to this one. Therefore, RP is equal to R square plus omega square L square by R. J omega LP is equal to J into R square plus omega square L square by omega L. Omega L. Omega L is far this impedance. Omega L is far greater than R. Therefore, RP is simplified to RP is equal to R square by R. R square by R is R plus omega square L square by R. Omega square L square by R. Omega L. This is the low value. This one is impedance of that inductor is omega L. Omega L is far greater than R. Omega L is generally greater than R. Omega square L square by R is greater than 1. Here belong omega L by R greater than 1. Omega square L square by R is also greater than 1. Therefore, this term is neglected. Rp is equal to approximately equal to omega square L square by R. Omega square L square by R. Here J omega LP. J omega LP is equal to J cancel. LP is equal to R square omega square L square by omega square L. Omega square L. This one is R square omega square L. Omega square cancel. Therefore, L. This low value. This is the low value neglected. Therefore, LP is approximately equal to LP is approximately equal to L. LP is approximately equal to L. In that equivalent circuit, the series combination is replaced with some parallel combination whose elements are RP and LP. RP is equal to omega square L square by R. LP is equal to L. LP is equal to L. Therefore, the equivalent circuit is replaced here is VS, RS, VI, B, RBB dash, this one is VB dash E, RB dash E. Input side capacitance is here is CA. Dependent current source here is dependent current source GM, VB dash E. Here in the circuit, R naught, C equivalent here, C equivalent. C equivalent is there. This one is R naught, R naught here. L and R is replaced with L and R is replaced with LP is approximately equal to L. This one is RP, RP. This one is RI. One more resistance is there. That is here is that is RI. V naught here, V naught, V naught here. At the input side, we have this equivalent circuit. At the output side, this equivalent circuit. LP, this one is LP is equal to L, RP, RI. Generally, you have to define two types of quality factors. Unloaded quality factor and the loaded quality factor. Unloaded quality factor. Unloaded quality factor. Unloaded quality factor means the coil quality factor, that is L and R. The quality factor Q of the coil at resonance is given by QR is equal to series for the series circuit omega R L by R, where omega R is the resonant frequency. The quality factor is called as unloaded quality factor Q. Unloaded quality factor. Coming to this one, effective quality factor. One more is there, that is called as effective quality factor. Effective quality factor. Effective quality factor. Effective quality factor including load can be calculated looking at the simplified equivalent output circuit for single tuned amplifier. The effective quality factor, the effective quality factor including load can be calculated looking at the simplified equivalent output circuit. Simplified equivalent output circuit for single tuned amplifier. For a single tuned amplifier. The tuned circuit consists of L and C equivalent, and the load is R0, RP, and RI. These three are connected in parallel, acts as load. That is RT. RT is equal to R0 parallel with RP parallel with RI. Along this tuned circuit, C equivalent and L. Generally, Q effective is equal to susceptance of inductance or capacitance by conductance of shunt resistance. Susceptance of inductor, susceptance of inductor L, or capacitance that is C equivalent by conductance of shunt resistance R. Conductance of shunt resistance RT. Because RT acts as load. RT is R0 parallel with RP parallel with RI. Susceptance of inductors. Generally, inductance conductance is equal to inductance impedance is equal to omega L. Omega L. Susceptance means 1 by, consider inductance. Susceptance of that inductance is 1 by at resonance omega R into L into conductance of that shunt resistance is 1 by RT. That is equal to RT by omega R into L. Consider inductance. Consider capacitance. Susceptance of that capacitance is C omega R into C equivalent. Yeah, susceptance of that capacitance. By conductance of that shunt resistance is 1 by RT. That is equal to omega C equivalent into RT. These two are equal. This is the unloaded quality factor. QR is this one is effective quality factor, means that is called as a loaded quality factor. With the load is RT. RT means R naught parallel with RP parallel with RA. Generally, load means consider input resistance of that next stage, the transistor output resistance R naught, and input resistance of the next stage acts as a load to the previous stage. R naught is the output resistance of the first stage. RA is the input resistance of the next stage. And RP is the resistance belongs to that tuned circuit. These three acts as load. That is the RT. R naught parallel with RP parallel with RA. Along with C equivalent and L. That is the reason that quality factor is called as effective quality factor or loaded quality factor. We know that generally RP is equal to, consider this unloaded, omega square L by R. Omega square, this is omega square L square by R. At resonance, omega R square L by R. That is equal to omega R L by R. This one is L square. Omega R into L. Omega R L by R is QR. QR quality factor for unloaded circuit. Omega R into L, that is RP. Therefore, QR is equal to, here unloaded quality factor QR is equal to RP by omega R into L. Only consider this series resistance is replaced with here inductance LP, and LP is approximately equal to L. That resistance is RP. Therefore, this unloaded quality factor, these two are equal. These two are equal. Unloaded quality factor is replaced with RP. RP acts as the load. That is RP by omega R into L. Here, this one is loaded or effective quality factor. Here include RT. Here include RT. Here include RP. This one is unloaded. This one is loaded. Here, general at resonance, omega RC is equal to omega R into L is equal to 1 by omega R into C. Therefore, QR is also replaced with RP by omega RL is equal to 1 by omega R into C. That is RP omega R C. Here, RT C equivalent into omega. This is also omega. Here RP is included. Here RT is included. This RT belongs to output resistance of the first stage, input resistance of the next stage, and also RP. Here only includes RP. QR is equal to. That is equal to next one is here. Here RP is equal to we know that omega R L by R and omega R L. Omega R L is equal to 1 by omega RC. Omega R L is equal to at resonance. At resonance, these two reactants are equal. Omega R L is equal to 1 by omega RC into R omega R L. Omega R is cancelled. Therefore, RP value here is L by CR. RP value is here is L by CR. This one is unloaded quality factor. This one is effective quality factor. Finally, that output circuit is replaced with input side Vs, Rs, B, RB, B dash, that is B dash. At the input side, this one is Vi, BB dash E, RB dash E. At the input side, that capacitance is Ca. This one is BB dash at the output side, GM, BB dash E. CB dash E. C equivalent included in this circuit is C equivalent. Next one is LP is approximately equal to L. Next one is RT. RT means already we know that RT is equal to R naught parallel to RP parallel to RA. This one is this is V naught. This one is V naught. Now we need to calculate voltage gain, output voltage by input voltage. V naught by Vi. Consider this one. Entire this one is Z. 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 Z means these two are connected in parallel. These two are for parallel combination. We need to use instead of impedance we use admittance. Y is equal to 1 by Z. Consider admittances. Admittance of RT is 1 by RT. 1 by RT. Admittance of inductance is 1 by J omega LP. LP is approximately equal to L. 1 J omega L. Admittance of that capacitance is J omega C equivalent. C equivalent. Here 1 by RT is the common term. 1 plus RT by J omega L plus J omega C equivalent. C equivalent into RT. Into RT. That is 1 by RT. Numerator and denominator is multiplied with some omega R, resonant frequency. J omega L into omega R. Here also, numerator and denominator is multiplied with omega R. J omega C equivalent RT omega R by omega R. Effective Q, we know that effective Q because RT is included, that is equal to RT by omega R into L. RT by omega R into L is equal to omega R C equivalent into RT. Already derived this one. RT omega R into L. These three parameters are replaced with the Q effective. That is equal to 1 by RT. 1 by RT. 1 plus this one is omega R by RTL omega R is here J omega. That is Q effective. Q effective. Omega R into RT by L omega R is Q effective. That is J omega L. Plus here J omega R is equivalent into omega R RT C equivalent. That is equal to Q effective. J omega Q effective by omega R. Q effective by omega R. Here numerator and denominator is multiplied with J. J into J square, that is minus term. Here J is common term. That is 1 by RT. 1 plus J is common term. J into Q effective. Here J Q effective omega by omega R. Omega by omega. Here that is the reason here minus sign. J into J square, that is minus sign. Omega R by omega. Finally here y is equal to 1 plus J Q effective omega by omega R minus omega R by omega by RT. Our requirement is Z, not Y. Z is equal to 1 by Y. Reverse this equation. RT by 1 plus J Q effective omega by omega R minus omega R by omega. This is the impedance Z. You have to introduce new term, that is dou, indicates the fractional frequency variation or selectivity or sometimes variation in resonance frequency. Have to introduce some new term. Let dou indicates the fractional variation. Fractional variation in frequency. Variation means omega is changed to omega naught, like that. Variation in resonance frequency or variation in resonant frequency. Generally, dou is equal to omega minus omega R by omega R. Variation. It is equal to omega by omega R minus omega R by omega R. That is equal to omega by omega R minus 1. Dou plus 1 is equal to omega by omega R. Therefore, omega is equal to omega R into dou plus 1. Here replaced with omega by omega R is 1 plus dou. Here omega R by omega is 1 by 1 plus dou. These two terms are replaced with newly introduced term, that is the dou, fractional variation in frequency. Therefore, Z is equal to RT by 1 plus J Q effective omega by omega r is omega by omega r is 1 plus dou. 1 plus dou minus 1 by 1 plus dou. RT by 1 plus J Q effective 1 plus dou into 1 plus dou. LCM is 1 plus dou here. 1 plus dou into 1 plus dou, 1 plus dou whole square, A plus B whole square, A square plus B square plus 2AB, 2 dou minus 1. These two are cancelled here. That is equal to RT by 1 plus J Q effective. Here dou is the common term. Dou plus 2 by 1 plus dou. 1 plus dou RT by next here is a 2 term 1 plus J Q effective. 2 is the common term here. 2 by 2 plus 1 by 1 plus dou. That is finally these two terms are neglected. Dou is less than 1. Fractional variation is should be less than 1 because omega minus omega naught is less than 1. Therefore, this term is neglected. Therefore, Z is equal to RT by 1 plus J 2 Q effective into dou. Dou by 2 is less than 1, and dou is less than 1. These two are neglected. Therefore, finally, Z is equal to RT by 1 plus J 2Q effective and dou. At the output side, consider output side circuit. Here, GM into VB dash E, GM into VB dash E. Entire one is here, Z. This one is Z. The output voltage here is V naught. Find out output voltage. Apply nodal analysis. The node voltage is V naught. The admittance connected to this, the impedance connected to this node is Z. That is the reason we use 1 by Z is equal to current away from the that node V naught is. That is the reason we use minus GM into VB dash E. Therefore, V naught is equal to minus GM VB dash E into Z. Consider this one is output circuit. Output circuit. Therefore, V naught is equal to minus GM VB dash E. VB dash Z is here Z is RT by here Z is RT by 1 plus J 2 Q effective loaded quality factor into dou. This is V naught. This is V naught. This is the equation 1. Consider input side circuit here. Vs, Rs. This one is B. Base spreading resistance RBB dash. RB dash E. VB dash E. CA is neglected compared to this one. Here at the input side, RBB dash E. This one is VI. The input side circuit here is CA is neglected. CA is neglected. Find out RB dash E. From this circuit, find out this VB dash E. VB dash E is equal to RB according to voltage division rule. RB dash E into VI. RB dash E into VI by RBB dash plus RB dash E. Substitute this VB dash E in that equation. Therefore, V naught is equal to minus GM into RB dash E into VI by RBB dash plus RB dash E into this one RT by 1 plus J 2 Q effective, and this one is dou. Finally, gain of the capacitor coupled tuned single capacitor coupled single tuned amplifier is A is equal to V naught by VA is equal to minus GM into VA is replaced here, bring this side, RB dash E by RBB dash plus RB dash E into RT by 1 plus J 2Q effective into dou. At resonance, the voltage gain. Find out the resonance means at resonance. At resonance, the voltage gain is A resonance. The voltage gain is A resonance. That is dou is equal to, we know that omega minus omega minus omega R. Omega minus omega R by omega. At resonance means omega is equal to omega R. Omega R minus omega R by omega R, that is 0. Dou term is 0. Therefore, A at resonance is equal to minus GM into RB dash E by RBB dash plus RB dash E into RT by 1 plus dou value is 0. Put dou value is 0. That is equal to 0. Therefore, A at resonance is equal to minus GM RB dash E by and RT also RBB dash plus RB dash E. A by A at resonance. A by A resonance. A is equal to generally RB dash E by RBB dash plus RB dash E. Compared to this RB dash C, RBB dash E is low. Therefore, RBB dash plus RB dash E is approximately RB dash E. These two are cancelled. Therefore, A is equal to minus Gm. A is equal to minus Gm RT by 1 plus J 2 Q effective into dou. This is also cancelled. Minus R at resonance is minus Gm into RT. Gm into RT. This minus Gm is cancelled, and RT is cancelled. Therefore, finally A by A resonance. A by A resonance is equal to 1 by 1 plus J 2 Q effective into dou. We use that magnitude for mod A by A at resonance. A at resonance is equal to 1 by square root of 1 plus 2 Q effective dou whole square. 2 effective whole square. Phase angle of that one is minus tan inverse J term is J coefficient is 1 by that one here minus means due to 1 by 1 plus J 2Q effective dou by 1. This is the phase. This is the phase. Two types. This is the unit circuit frequency response here. This one is omega R. This one is A by A resonance value. This one is gain. 1 by root 2 times A by A resonance. This is one. This is omega 1. This one is omega 2. Bandwidth is equal to omega 1 minus omega 2. First, we need to calculate at omega 1. At omega 1, at lower 3 dB cutoff frequency. At lower 3 dB cutoff frequency, that means omega 1 is less than omega R. At that instant, the gain is 1 by, this one is 1 by root 2 times 1 by root 2 is equal to 1 by square root of 1 plus 2Q effective dou whole square. These two are equal. Therefore, root 2 is equal to square root of 1 plus 2Q effective dou whole square. 2 is equal to 1 plus 4 Q effective dou square. 4 Q effective dou square is equal to 2 minus 1. That is 1. Dou square is equal to, this is Q square. Dou square is equal to 1 by 4 Q effective square. Q effective square. Therefore, dou is equal to plus or minus. Dou is equal to plus or minus 1 by 2 Q effective. For this case, omega 1 is less than omega R. Omega 1 is less than omega R. Therefore, dou is equal to minus 1 by 2 Q effective. Case 2. Omega 2 is greater than omega r. In that case, dou is equal to 1 by 2 q effective. In both the cases, omega 1 and omega 2 cases, the gain is decreases 1 by root 2 times that one. A by A resonance. A by A resonance. Next, calculate bandwidth. Bandwidth is equal to resonance frequency by quality factor Q effective. Q effective. That is equal to omega r by Q effective is RT by omega r L. RT by omega r L. Omega r by RT by omega r L for inductance is equal to omega r C equivalent into omega r C equivalent into RT. RT by omega r L is equal to omega r C equivalent into RT. Omega r is cancelled. That is equal to bandwidth of that unit circuit. Bandwidth is equal to 1 by RT into C equivalent. Gain bandwidth product at resonance. Gain bandwidth product at resonance. At resonance is equal to gain at resonance into bandwidth. Gain at resonance is minus GM into, we use mod term, minus GM into RT. Bandwidth is 1 by RT C equivalent. RT cancel. Therefore, we use modulus GM by C equivalent. Gain bandwidth product. With this, the analysis is completed.